All right, see people joining us now.
Hello, everyone. Thanks for joining. This is our fourth Global Learning Seminar, Madi? Yes, it is. And we are delighted today to combine our Global Learning seminar with an overview on Sea Level Solutions Day, how you can participate in Sea Level Solutions Day, and focusing specifically a bit on sea level rise and king tide flooding and some solutions around Miami-Dade County. So my name is Tiffany Troxler. I'm the Director of Science of the Sea Level Solutions Center. And our program is co-hosted by the Department of Journalism and Media in the College of Communication, Architecture, and the Arts. And our program is funded by Miami-Dade County Environmental Education Program. So we're gonna launch right into it with a quality of life poll. So if you've already taken the quality of life poll, please take it again. We appreciate your participation. Take it away, Madi or Alyssa.
Yes, I'll be doing it.
Hi,
Hi, everyone. So you should be seeing a pop-up on your screen with the poll. The way the polls work is you have to answer at least one answer on every question and scroll all the way down to press submit. I'll walk you through these questions, but like Tiffany said, if you've done this before, please do it for us again. We want to see what kind of group we have with us today. So the first question reads, I am non-student or student. The second question, the type of business where I work is private sector, government, nonprofit, self-employed, and I'm not working. Number 3, what are the 3 most important things that determine your quality of life? This is a multiple response question, so you can answer multiple answers. You have health, family and friends, happiness, freedom, learning and education, religion, being outdoors and connecting with nature, work-life balance, safety and security, and let me scroll down, good pay or job. I'll give you about a few minutes to complete this poll. Number 4, what are the 3 most important concerns you have about sea level rise and flooding? Also a multiple choice answer. Applying science to make good decisions to address these issues, increasing threat from storm surge, impacts to property or property value, lack of awareness and no action to address it. I skipped one, impacts on community, family and friends, impacts to natural habitat and wildlife, exacerbation of social inequities, relocation, water contamination and public health impacts, and impacts to infrastructure. Number 5, what are the 3 most important concerns you have about other impacts of climate change? We have a question here that says number 5 is only letting them select one option for when it asks for the top 3. Madi, if you can check that out for me.
Yeah, give me one.
Should be.
On question number 5, it says, okay, it appears to only let me select one option. When it asks for 3,
well,
should be a multiple response.
If that's the case, then I guess just choose your top one. If it lets you select multiple.
I don't have access to click on it myself, but
okay.
I guess, yeah, if it asks for the top 3, just select your top one. Is anybody else having the same issue, not being able to select more than one?
Yeah. Okay. All right. Technical difficulties. So like we said, just choose your top choice.
Thanks,
and
guys.
And we'll jump to number 6. What do you think are the 3 highest priority initiatives or actions that can be done to reduce the impacts of climate change and improve your quality of life? Increase use of renewable energy, use bonds or small increases in taxes to reduce greenhouse gas emissions and finance projects to reduce climate change impacts. Increase city and community initiatives that support household activities like composting, eating less meat, and planting more trees. elevating buildings and other infrastructures, update codes, planning, and infrastructure based on the best available science, increase city or community green infrastructure initiatives like tree planting, vegetating swales, and increased restoration of coastal habitats, supporting low wealth communities, increasing community awareness and education, move to lower risk neighborhoods, and improve water management. So we're already reaching 80%. I'm gonna end the poll with that and share the results. So we have mostly students, but also a good portion of non-students with us today, most of which not working, if not working for the government sector. The three most important things for this group are health, family and friends, and happiness. The three most important concerns would be applying science to make good decisions, as well as impacts on natural habitats and wildlife, and impacts on family and friends. Number 5, the top one concern related to other impacts of climate change, where we have a tie between applying science to make good decisions and impacts on habitats and wildlife. And the last question, the 3 highest priority initiatives would be increased use of renewable energy, increasing community initiatives, and increasing green infrastructure initiatives. Thank you so much, everyone.
Thank you, Alyssa.
All right, let's get into the second portion of our program. We're gonna do a little introduction on sea level rise, king tides, and sea level solutions. So what is climate change? Let's just start with climate change so we're all on the same page. So this is some of the evidence that helps us to understand what is happening in our environment related to climate change. So if you look at this graphic here, we have on the horizontal axis is hundreds of thousands of years before present. And on the vertical axis is atmospheric carbon dioxide concentration in the atmosphere. And what that blue line, that wiggly blue line is showing is that we've had a fairly stable carbon dioxide concentration in the atmosphere. And these are data that are reconstructed from ice cores that built up over hundreds of thousands of years in land masses like Antarctica. And so carbon dioxide is trapped in the atmosphere over that time frame, that very long time frame, and the carbon dioxide concentration is reconstructed to show us that over that period of time, we didn't see carbon dioxide concentrations greater than 300 parts per million in the atmosphere. Until recently, until within the last 100 years, we've seen an acceleration of the rate at which carbon dioxide is increasing in the atmosphere. And each time I show this slide, I teach a class in the spring, and I have to update the carbon dioxide concentration. And here, this one was from 2019, we were up to 410 parts per million. And these are measured data. These are measured in Hawaii. And we know that based on those observations, what the atmospheric carbon dioxide concentration is. So this is a big acceleration related to the increase in greenhouse gases in the atmosphere, these heat trapping gases. Next, please. So the increase in these greenhouse gases, they're very efficient at trapping heat, like carbon dioxide, methane, nitrous oxide. And what these graphics are showing here is that as the carbon dioxide concentration increases, the heat in the atmosphere increases, and a lot of that heat, around 90% of that heat, is absorbed by oceans. And that translates to increasing ocean heat. And as the ocean warms up, it also expands, which is one contributor to global sea level rise. And we have multiple lines of evidence that come from world-class organizations that are constantly studying the information that helps us to understand what's going on in global climate. Next, please. So I mentioned one of the contributors to sea level rise. This is the expansion of oceans as they warm up. So that's thermal expansion. We also have a contribution from meltwater, so land-based ice as well as glaciers melt and contribute to what's called meltwater, and that also contributes to global sea level rise. And then exchange of land water storage is another contributor. So when we're moving more water off of the land into oceans, that can also contribute to global sea level rise. And then we also have something called regional sea level rise, which is what we observe here locally. And this can be that the change or the difference from the global sea level can be or is attributed to the changes in the mass of ice. So as land masses get larger or smaller, their gravitational influence also changes, and the ocean responds to that and redistributes ocean levels. And that's one contributor, ocean circulation. So the Gulf Stream, if it's moving slower or faster, that can also contribute to the level of the sea that we observe here locally. And then also land movement, so vertical land movement. If the land is increasing, or the height of the land is increasing relative to the sea level, we're going to see observe a different relative sea level than if the land were subsiding. And we do have evidence in the Everglades, for example, of some land subsidence, but it's typically only observed in very isolated locations in around Miami-Dade County. Next, please. And so, I talked about reconstructed carbon dioxide concentrations and observed carbon dioxide concentrations in the atmosphere. We also have observed sea level that's been measured actually in Key West for the last 100 years. So what you see there on the left, upper left panel, is the change in sea level over 100, or I think that figure maybe does not, maybe I'm not sure if that one actually goes back to 100 years, but we've observed about 9 inches of sea level increase over the last 100 years at our Key West tidal station. And what you see here in the larger graphic are projections of sea level change in the near term and the long term. And these different lines, these different projections refer to different socioeconomic conditions that either represent what we would refer to as business as usual. So business as usual means that we're emitting carbon dioxide and other greenhouse gases at the same level that we are now, and we do nothing to increase the share of renewable energies or try to increase carbon removal to pull some of that carbon dioxide out of the atmosphere. And so that would be represented by this extreme line. There's so much uncertainty in what those lines and what those points look like as you go farther into the future, but it gives you an idea of the relative difference in global sea level depending on what sort of actions we take around the world to reduce our emissions of greenhouse gases. And then in sort of the near term, if you look at the 2020 to 2070, so this is a planning horizon. So this graphic is also very useful for planning infrastructure and planning new developments. If you want to build a development in a low-lying area and you want to make sure that it doesn't get flooded, then you're going to plan that development for a higher level, a higher projected level of sea level rise. And that's another way in which this graphic is used locally by our counties to try to protect the future of infrastructure. Next, please. And so what has come upon us now is the season of the king tides. And so what happens, gravity is upon us again, and the influence of gravity has a bigger influence on Earth's tides during this time of year. And so that can increase the sea level that we observe up to 2.5 feet over the mean tide. And so, and in this, and so that's what, so, and this happens seasonally. So in March, April, we have high tides or higher high tides, and then the highest high tides are in the fall. And we refer to these tides as the king tides, and this is influenced by the tidal variation on top of our change in sea level locally. Next, please. And so in some areas, this tidal flooding can, or this tidal variation can contribute to tidal flooding that we observe on the land surface. So can you go back one really quickly? Yeah. So so in one case, you may be, in a neighborhood and you see no flooding, and then due to the variation in the tide coming up, go ahead, Mani. You can see flooding in certain locations, and these are most often in low-lying areas and near the coast or other waterways. Next, please. And so this graph, I always spend way too much time talking about it, but I'll just say really briefly that, remember those curves, those projections that we showed in the sea level rise graphics. So then you consider the potential change in sea level. So take the case of the extreme curve. That also has an influence on the number of these tidal floods that we may observe in certain areas that are low-lying. So the higher the sea level that we observe, the more tidal flooding events we are projected to see. Next, please. And so we know that the impacts of sea level rise are already here, and part of what we do in Sea Level Solutions Day is go out into the field and try to understand where, when, and what the extent of this flooding is during these seasonal high tides. And we observe this, as I mentioned, in tidal flooding events in some low-lying areas. Sea level rise also has an influence on our different aspects of our infrastructure. So a lot of our infrastructure was built for static conditions. We weren't anticipating sea level to change when we built a lot of the infrastructure that we have here in South Florida, nor our water management system. So what we're now trying to understand is how can we redesign, retrofit, change that infrastructure to be less vulnerable to changes in sea level. Next, please. And so compound flooding. So this is referred to as a threat multiplier. So I talked about the change in sea level, talked about the tidal variation on top of the sea level. There's also the influence of storms and tides, which can contribute to flooding, groundwater levels, which in some areas are quite close to the land surface. If there's higher groundwater levels during, let's say, the summertime, the wet season, when our aquifer is filled up with water, that when it rains, there's no place for water to go if the water table is very close to the land surface. So depending on the position of the groundwater, it can also contribute to flooding. And then, as I mentioned, precipitation, and then water that's coming down our canals. So when you add all of those different sources of flooding together, we refer to that as compound flooding, which increases the risk of of flood impacts. Next, please. Thanks, Mani. I paused a little bit there. You're doing great. So this is an example of compound flooding that we observed in a neighborhood where we do conduct these citizen science-based flood reporting, flood monitoring. And this video, it's a drone video that was shot by Dr. Jacobson's student, Colin Simpson. And we probably have this video on our website if you want to take a look at it afterwards. But in some areas we can observe quite a bit of flooding related to these king tide events. Next, please. So let's just briefly talk about solutions. So when we talk, so there are essentially two types of solutions when we talk about climate change. One is mitigation, and those are activities that focus on reducing the causes of climate change, like reducing carbon dioxide emissions is one form of mitigation. And then adaptation. So these are activities that reduce the effects of climate change. So an effect of climate change may be flooding. So an adaptation action might be to adjust something about the natural or the human environment so that you're reducing the effects of flooding on humans and the environment. Next, please. And so Miami-Dade County has been working very hard to develop a sea level rise strategy that is focused on adaptation. Some of the activities here also do provide mitigation benefits. For example, if you were to take an adaptation strategy that includes a lot of, let's say, green infrastructure or natural habitats, that also can have the effect of reducing the causes of climate change by sequestering more carbon dioxide from the atmosphere and putting it below ground or in treed biomass. So in that way, you can get multiple benefits out of investing in adaptation. So you'll be seeing more about this in the future, and we'll make sure that once the strategy is released, we'll have that information on our website and direct you to the Miami-Dade County website where this will be posted. But some really exciting opportunities for redesigning, retrofitting, and improving our environment as we adapt to sea level rise. Next, please. So that concludes it. There are lots of other solutions that we could talk about. Just wanted to leave you with that. We'll go to the next segment of our program, which is the How Did We Do poll.
Awesome. Thank you so much, Tiffany. So we are launching another poll. This one's shorter, just 4 questions. And I'll walk you through them again. We'll give you a few minutes. Once again, you have to select an answer for each question and scroll all the way to the bottom and press submit. So the first one says, what causes global average sea level to rise? Excessive heat in the oceans caused by warming, melting of land ice in Greenland and Antarctica, melting of glaciers around the world, or all of the above. Number 2, the rate of rising sea level in the vicinity of Miami-Dade County is different from the global average. Why? Redistribution of land-based ice causes Earth's gravitational field to change. Changing ocean currents such as the Gulf Stream, or all of the above. Number 3, flooding in coastal areas of Miami-Dade County may be caused by blocked local drainage, inability of canals to discharge local floodwaters, rising groundwater levels, rising sea levels, and excessive rainfall, or all of the above. And the last question, what are the flood threat multipliers? Sea level rise, increasing rainfall, rising groundwater levels, and all of the above. So we have about 40% right now. We'll give it, hopefully we make 75, 80%.
And it's not being graded for our global learning students.
Not hunt you down. Almost there. Oh, can we hit 80? I think we could.
80, 80.
80, 80.
Virgil's last few people.
One more, one more.
There we go.
Ooh.
Oh, that didn't make 80 though.
One more, one more.
Let's see. I'll give it a 215 and then we'll end the poll.
Come on, just one
I'm
more.
still hopeful. All right, I'm going to end the poll. 79 is good enough. And I'm going to share the results with you. So number 1, what causes global average sea level to rise? Yes, all of the above. Excessive heat, melting of land ice, and melting of glaciers. The second question, all of the above as well. So good job on that. I think that's a good giveaway, right? Number 3, flooding in coastal areas of Miami-Dade County may be caused by, correct, all of the above. And number 4, what are the flooding threat multipliers? All of the above. Good job, guys.
Okay. Now we're gonna, let's move this poll, talk about Citizen Science and Sea Level Solutions Day, what we're gonna be doing. And we're hoping that everyone who's participating today will consider joining us. This is on Saturday, October 17th. And it is an activity where, well, we usually bring people together for a big event, but this year we're having sort of a, we're having these webinars, but also still able to send people out into very small teams to sample floodwaters. Next. So what are we going to be doing? Well, what the work is intended to improve information about where, when, and to what extent king tide flooding occurs and what the quality of that water is, and have fun doing it. And the real opportunity working as a group of citizen scientists is that it really is not possible to collect information across Miami-Dade County during an event like this without bringing people together to participate as citizen scientists. So we both appreciate this as an opportunity to learn more about sea level rise and king tide flooding in our neighborhoods in particular, but also to collect scientific information that can help us to design better adaptation strategies. And also, other types of opportunities like developing flood warning systems that help people have more information about how to avoid the impacts of flooding. Next, please. So Madi has a couple of photos of some of the past events. Vizcaya has always been a great partner in these events over the years, Vizcaya Museum. And so this is sort of a flow chart of what we'll be doing. So Dr. Jacobson is going to talk to you a little bit about the Eyes on the Rise application. So what we do is we use that application, which is simply gives you an idea of where low-lying areas occur and estimate the areas where we might expect flooding with tidal events like we observe some years with king tide. So we use that to identify places where we can send teams of citizen scientists. And then what we're doing today is teaching you how to, we're teaching you how to locate that site, and that will, we provide that information in the citizen science kits that we provide you, and then also provide you with information about how to document the flooding. And then you go to the site with your citizen science kit, and this year we have station leaders that will be picking up kits at locations, at designated locations, and participants who will join the station leaders to help with the sampling. And then your small team works together to collect information, to collect flood height to collect salinity of the water using a refractometer, and then taking some water samples so that we can analyze those samples for nutrients, carbon, and the presence of fecal indicator bacteria. And these pictures that you see here are the types of pictures that we ask you to take so that we can verify the information that you will be entering into a smartphone application that Dr. Jacobson will talk to you a bit about more and has also designed. And so that smartphone application takes, collects, you upload the photos, you can manually enter information like flood height and the salinity that you'll detect with your refractometer, as well as the sample bottle numbers and pictures of those bottle numbers so we can keep all of our water quality samples straight. And all that information comes to us through this smartphone application. And then we compile that information that all of our citizen scientists collect and post that on the MESON website, which Susan will introduce to you shortly. Next. Yeah, so this is an example of, just shows one neighborhood where we've collected observations in the past. You see there on the left is a legend that shows the different flood heights that were documented in areas of this neighborhood. And you can see that the flood height changes over the tidal cycle. And those different colored dots refer to the times at which those flood heights were documented. Next, please. And now we'll go to our portion of the program led by Dr. Jacobson. And Susan, please go ahead.
All right. Hello, everybody. My name is Susan Jacobson. I'm a professor in the Department of Journalism and Media. And so I'm going to do a couple things. I'm going to show you an application that we use to help determine where tidal flooding might occur, another application that helps us determine when it might occur. I'm going to show you a couple of examples of data that we have collected. And then we have a video and a walk through our smartphone app to show you exactly what you will be doing and using on the day of the King Tides Citizen Science, the Sea Level Solutions Day. Okay, I'm going to share my screen. Okay. So I'm going to show you these applications first, and then I'm going to, I'll give you a QR code where if you're interested in seeing them, you can see them for yourself. Okay, so, so this is the Eyes on the Rise application, and you can get to it from eyesontherise.org/app. It's an interactive sea level rise viewer, and what it does is it shows you, it gives you an idea of where flooding might occur. It actually uses an algorithm that was developed by the GIS Center here at FIU that combines both the elevation and and location near waters and projected sea level rise height to give you an idea where flooding might occur. So the way you do it is you enter in your address. So I'm going to enter the address of the BBC campus. Let me say FIU, BBC. Okay. Oh. Okay. All right. Well, it has landed on a location at the Biscayne Bay campus in the middle of the pond here, and it says our elevation is 0.77 feet. For some reason, it usually puts this on a here at the library, which is a little bit higher. There we go, 7.12 feet. That's funny, I must have pulled that down from the Google search menu. Okay, so if you're at the academic one, this is academic one right here. So if you're in academic one, it's about 7 feet at BBC, which is actually pretty good if you know something about the elevation in South Florida. I think the average is about 3 feet above sea level, so 7 isn't bad. But what happens when we add some sea level rise? So this little slider lets you slide along and see what would happen if up to, say, 6 feet of sea level rise without any mitigation, what it would look like. And it takes a minute actually to paint. And it will probably, the water will start coming in if I zoom out. There we go. So as we can see, at 6 feet of sea level rise without adaptation, without any solutions to try to modify the impact that this would have. Although you might be high and dry and academic too, you will have to swim to your car in the parking lot and possibly take a boat from US 1. So there you go. All right, so we use this map to kind of give us an idea, and I'm going to zoom out to show most of Miami-Dade County, to give us an idea where some of the floody locations might be. And then that's where we assign people to go, because this map gives us an idea where, when there's high tides, where there might be some flooding. Okay, now we use another application to tell us when all of this might happen. And this one is called the High Tide Calendar. And it works on a similar principle. I'm going to enter the BBC campus again. Let's see if I end up in the, nope, okay, back on at the library. Okay, and what this does is it takes your location and then it finds the closest tide monitoring station. Now there's about 500 plus tide monitoring stations around the state of Florida. And it pulls the data from the NOAA tide tables and it puts into a little calendar. So this weekend is the 17th and 18th of October. And these are when there are going to be some of the highest high tides of the year. So on the 17th, the high tide is at 10:37 a.m. and it's going to be about 3 feet plus. These numbers tend to be not quite accurate. They're estimates, but we understand, but relatively speaking, this is a pretty high number for this location for this year. And on Sunday as well. So we are going to send people out on Saturday the 17th around 10:30, just before 10:30, at 10:30 to take some samples. And if you live in an area where that is where you see flooding during the high tides, you can use this application to figure out when there might be flooding if you live in a location where that happens. Okay, the last thing I'm going to show you is a little map of some of the work that we've done in the past. This is the map that Tiffany showed before this is from Shorecrest on October 7th. This is post Hurricane Irma that dumped a lot of water. So just to show you the 3 different times that we sampled. And then this is just from one of the times. And if we click on one of the dots, let's see, we try this one. So this gives us the location. It gives us the date and time that this was taken. It'll give us a context of the flood. So we can see it was quite floody on that particular day. This provides us with the context. And then we also ask people to do things like take a water depth photo. So when you use the application, one member of your team will put the measuring stick in the water to measure how deep it is. Another person using the smartphone application will enter that number in the smartphone field and also take a picture of the stick in the water so that we can verify it. All right. Okay, and I'm going to show you a PowerPoint slide that has a QR code with the URLs with both of these applications. Okay, I'm going to give you just a minute if you want to capture that. And next I'm going to take you on to a QR code for the actual application that we will be using on Saturday to collect the sea level rise data. Okay, so we can put these URLs in the chat. Oh, there we go. So this one is the app that you will use to collect data on Saturday. And the URL is here. You can take the QR code, you can type it in. One of the things that will probably happen is it will ask for your location. When you're out in the field collecting the data, say yes. That's how we get an accurate location on the map. Okay, I'm gonna stop for just a moment. Mari, I think you have a slide that I don't have. So I'm gonna hand it back to you for now.
Awesome. I think we're ready to show the video and how they can implement it to the citizen science application.
Okay, is there one more slide before that? The slide with the map?
Negative. I believe we covered everything.
Okay.
But, yeah.
All right. Okay. Yes, we did. All right. So We have a little video that shows how you, what you're supposed to do when you when you go out to do the sampling, to do our citizen science sampling, and it's pretty thorough. I will tell you though, we made this in 2017. We use a slightly different smartphone application, but it's the same process. Okay, so I'm gonna go grab the, I'm gonna share my screen and I'm gonna play the video. Okay, all right, let me go find the video here. I think it's here. Yes, it is. Okay, full screen and play.
Manager with the FIU Institute of Water and Environment, and I'm here to help explain in a how-to video how to use the citizen science sampling kits that we provide for king tide flooding events with the Sea Level Solutions Center. So this year's Sea Level Solutions Day is going to be November 4th, 2017, and we're going to be taking citizens out, students, teachers, residents, and FIU scientists and researchers out into local communities to conduct citizen science measurements of king tide flooding. And we're going to be distributing kits that will help provide all of the tools and information that you'll need to conduct the sampling. And we're here to explain how to do that step by step. So the first thing you're going to do is check inside your citizen science kit that we provide for an information packet on how to download the app and register, sign up for the king tide sampling. It will provide a form for you that's going to have all of the information that you're going to need to input, and it will give further instructions. And the first thing that we're going to have you do is go out in teams to different sites that we have located on a map, also inside your kit. And that's going to tell you step by step what you need to do to conduct the sampling. So each citizen science team is going to need at least 2 people, one person to conduct the actual measurements and the other to input the data into the phone through the app and take pictures throughout the process. One collecting the data. The first thing you want to do is put on your gloves. All right, so you want to have your gloves because you are going to be getting wet. You're also definitely going to want to have high boots. Rain boots, rubber boots are best because some of these events can have 2.5 feet of flooding, and so you will get wet, and that's another reason why you want the gloves, because you're going to be using your hands to actually conduct the measurement. So the first tool you're going to be using in your citizen science kit is the tape measure, and you're going to be recording the flood depth. So you're going to take your tape measure and extend it so that the 0 is facing down, and you're going to put it in the centermost part of the flood where it's deepest and record the depth in inches. And then you're also going to want to have the second person take a photo of that depth close up so that we can see where the water line is and verify that that's how deep the flood is. So the next step is to measure the salinity and see if there is any salt content in the water in the flood. You're going to take your refractometer and your pipette, which is an eyedropper. You're going to stick your pipette into the flood below the surface and squeeze so that you can draw some water in. And then you're going to flip open the lens on the refractometer and drop some of that water onto the tip, close the lens again, and then look through the eyepiece. When you look through the eyepiece, you should see a little gauge, and you're going to look on the right side for parts per thousand salinity. It should be a number somewhere between 0 and 30, 30 being salty bay water and 0 being fresh water. So look for where the dark blue line and the light blue line meet and record that number again between 0 and 30. You also want to take a picture, if you can, with your phone of the reading that the refractometer is getting, and you want to make sure that there is enough light coming through here so that you can see the actual reading on the eyepiece. When you're done, clean off the refractometer with your cloth. Next, you're going to be taking a sample of the flood with a bottle that is included in your citizen science kit. So you want to take your sampling cup and stick it upside down and put it directly into the water so the water is up to your wrist but not going above your glove, into your glove. And then you want to tilt it sideways. We don't want to collect any of the debris and stuff floating at the surface. So you want to stick it below the surface, tilt it sideways, let the bubbles come out, and then tilt it up so that you can then remove it, cap it, and put it back into your citizen science kit. Then also take a photo of the bottle with the label on it that verifies that that's the sample from that place and time. So finally, you want to make sure that you have taken enough photos of the surrounding area so that we get a sense of context, and if we go back to repeat a measurement there, we can find exactly where you sampled from and repeat that measurement and get good information. So you want to look for landmarks that will stand out, a stop sign or a lamppost. And if you can, measure how far away your sampling site was from that location. So you also want to take a close-up shot of the flood as well as a zoomed out photo to give that context and background for where you took the sample. Make sure that you have taken all of the data that the app asks for. If there are any other notes that you want to make about the location or a description of the flood, feel free to do that as well. You can take a short video, but please no more than 2 to 3 seconds if the flood is bubbling or moving, and that will help us get a sense of where it actually is. If it's located near a storm drain, these are places where we want to get information about the flood. And then finally, when you're all done, remove your gloves. And we also have included hand sanitizers so that you can clean up at the end, and then you're all set.
Okay, so I'm going to walk you through, if I can get out of YouTube here, I'm going to walk you all through, I'm going to walk you all through the, how to use the app. So I'm going to put the, I'm going to put the URL into the chat. Here we go. And I'm going to go to the application itself. Okay.
Susan, just make sure to reshare your screen once you're done.
Oh, yes, I'm sorry. Oh, my goodness. Somehow I stopped sharing my screen there. Okay, here we go. All right, so I put the link to the application in the chat. So if you want to play along, you can do this. It's a web app. It's not a native app. You don't have to download anything on your phone. All right, so when you get to the site, you're going to go to this app. You're going to put in the name of your group, the name of your group leader, who is the station leader. And if you want to add the name of the group members, that's fine. Let us know what kind of phone you're using. We use this for quality control purposes to make sure that our application works across platforms. Make sure you enter the date. This will populate with the current date and time, but if it doesn't reflect the correct date or time, then please change that. It will also, when you open it, it will probably ask you for your location or permission to use your location. Please say yes if you can, because then it will automatically put your location here. If you don't see it, you can enter an address here. And if the map is just not working for you, just put the address or put a description of the location down here so that we can match your data collection with the location later on. Okay, so like I mentioned in the video, the first thing you're going to do is one person is going to do the measurement and one person is going to use the smartphone application. So the person doing the measurement is going to stick the yardstick into the water and read out the number of inches of water, standing water, and the person with the smartphone application is going to enter it here. And the only depth measurement that we're using is inches. Then you're going to take a picture. You're going to take a picture of the stick in the water so that we can verify it. You're going to do the same thing with the refractometer. Now, the refractometer showed us how to use, the video showed us how to use the refractometer. There are two readings. The one you're looking for is the side that goes from 0 to 30. You want to put that number here and then try to take a picture of that. You're going to take some water samples. Please take a picture of the bottle number so that we can associate that with this location. You can describe the standing water that you're seeing. And then really important, take a close-up of the flooded area, possibly where the source of the water is coming from, and then take a context of the standing water. Like we want to see the neighborhood, the environment where it's located. And then video of the flood if you want to. If you see a contamination source, you can put that here. If there's anything else you want to know, put it here. And as the little sticky note says, don't forget to hit the submit button, and then hit the submit button. Now, if you have a bunch of photos and video here, it might take a minute for it to download. And if you get lost or forget, you can click the instructions here. We have the video and we have pretty much step-by-step instructions. Okay, I'm going to stop sharing.
Awesome. Thank you so much, Susan, for your presentation. Now I'm going to go ahead and take the time to show you all how you can register for this event and some key things to keep in mind. So I'm going to guide you
The
through
deadline is tonight, right, Madi?
Yes, indeed. So
Yes.
please register tonight. We're closing registrations today at 11 p.m. So we make sure we can make the groups necessary for the event. So basically, because of COVID, we're making groups of 3. We are providing you the exact location where you would be sampling the event. So we have 2 kinds of registrations. We have a site leader and an attendee. The site leader is responsible for taking their kids to their site location and perhaps taking on that leadership to show the attendees how you can use a refractometer and pretty much guide your team through that process. So the event will start at 8:30. We ask the site leaders to be on site no later than 9:30 because the first water sample we'll be doing, it's going to be at 9:45 a.m. and the second water sample, it's going to start at 10:45 a.m. So that's why we kind of gave you the 8:30 a.m., but please be there a little bit earlier before 9:30 a.m. So that information is all available here in the registration page. We did ask, let's say if you meet somebody this afternoon and you want to invite them for the event, ask them to register, but it's very important that they attend one of these webinars, one of these training sessions, and we'll have one available on Saturday before the event from 7:30 a.m. to 8:30 a.m. Also, you can participate if you just want to rewatch the instructions. So if you decide to take on that leadership and become a site leader, we are having a window to pick up the sampling kits at the FIU BBC campus, which is located on Biscayne and 151st Street. And we'll have a window from 3 p.m. to 6 p.m. If by any chance you, I don't know, let's say you got stuck on traffic or you may need to arrange something, you're welcome to email our colleague Maria Pulido. Alyssa and I will also leave our emails just in case, but we really ask you to please stop by 3 to 6 p.m. essentially tomorrow. All right, so let's take a look at how the registration page looks so you can select your preferred location. We're essentially going to give you a general location now. So let's say, yes, I want to be a site leader, or maybe you are bringing your dad as well. So you can register more than one person. So you can go ahead and register here and I'll guide you through the process just as a test. And this is my email, which by the way, you can email me if you like. All right. And then you will fill out your personal information here. If you're comfortable giving us your phone number, please do. Okay, so here where it says, please select your preferred general sample locations. Again, we're doing groups of 3, so we have limited capacity. And this is exciting to see that some of them are like, quotes unquote, sold out. But we still have some available locations to become a site leader. These are the ones that I'm seeing available at the moment. Let's say you'll choose Morningside Park. And so remember again, the site leader is responsible for picking up the sampling kits. You can stop by tomorrow from 3 to 6 p.m. at the BBC campus. And this is for us to know like where you were able to attend one of these training sessions, but most of you attended it today. So you can just click on that and you just hit the register button. Once you register, we're going to send you an email confirmation with the exact location, the map, your site leader, and your group. So that's pretty much it. That's for the registration. But if you have any questions, we're about to jump on that. So feel free and we can raise your hand and unmute you if you have any questions.
So we did receive a question. If only station leaders are required to pick up the kits. Yes, the station leaders are the ones that are supposed to pick up the kits. However, there are some cases where certain sites and teams did not get a station leader. So our colleague Maria Pulido is reaching out to participants to see if they can work something out. We also have, if there are multiple people per site, how would we space out at that site? Essentially just keeping the 6 feet distance that, you know, we all have heard about, making sure that you bring your masks. That's very important as well. For example, if So if you designate somebody to use, to be the photo taker, you're not passing around the phone. It's that person and that person only throughout the entirety of the event. And if, I think that pretty much covers it. Tiffany, you want to jump on anything with that?
Yeah, thank you.
Okay, perfect. We also had a question come in earlier, which I did answer on the Q&A, but I'll repeat it. How many samples is each team supposed to collect at their site? It's 2 samples, so 2 water samples. And then you can also sample I have the tape measure here. The flooding, you can do it multiple times, but we asked just 2 times mostly.
And we'll have hand sanitizers ready for you at the site. We provide the gloves. And like Alyssa said, thank you. We will be following all COVID-19 protocols. That's the reason why we're doing the groups and site leaders. All right.
We also received a question, where on the FIU Biscayne campus do we go pick up the kits? So there's a specific room where our colleague Maria Polito would be coordinating. I'm not sure the exact room number, but she's the one that will give you the directions and be on call so you guys can meet up.
So
yeah, once you register, that information will be specified, but I think it's also in the registration page.
right, it's right here. It's AC1331. So that's pretty much the middle building, if I'm not mistaken. But if you click on this, it's going to guide you to the particular site.
And then if for some reason you can't go to BBC, Maria will also work with you to designate a different arrangement to pick up the kits.
We had another question. Is there a recommended day to drop off the samples? So we asked, Tiffany, do you want to take that? Or?
Yeah, so in the registration page, it also specifies when to bring back the kits, and that is to Maria Polito after the sampling's conducted, and she'll be there until 3 p.m. But if you need to arrange something else, that can be organized with Maria, but we highly encourage you to try to get those to BBC, because there will be a lot of people with a lot of kits that we're trying to coordinate that day. So please bring those kits back to Maria, and then we will be handling the water samples from that point afterward.
I see another question coming in. I was wondering if there's any information you can send me about today's webinar. Absolutely. If you don't mind, here, I'm just going to send you my email. If you don't mind sending me an email, I can send you the recording of this webinar. You'll be able to rewatch it, but you can also participate again in Saturday's webinar from 7:30 to 8:30 a.m. Are we dropping them off, or where
Yes.
we pick them up? Yes, exactly. The same place that you are picking up the kits, you will drop them off. All right, I'm gonna stop sharing here. And I think we're ready if there's, okay, so what time is the webinar on Saturday? Okay, the webinar is gonna be at 7:30 a.m. It's also in the registration page. Bring your friends, bring your parents, have them come out and yeah, talk to them tonight, see if they can register, or email us. If you've met anybody that wants to participate and it's past the registration, you can email one of us and we'll make the accommodations needed.
Awesome. All right. So now it's time for our last poll, right, Mari?
Yes, and in the meantime, I'm gonna reshare that registration link one more time.
Awesome. So I'm launching our last poll, and it's just a satisfaction survey. We want to know how we did today. So the first question, how would you rate today's webinar? I enjoyed it. High 5. There's some aspects you liked, but not everything. It was okay. Could have been better. Terrible and a waste of time. And I do not prefer that. I prefer not to answer. Number 2, would you like to participate in an upcoming citizen science monitoring event? Yes, no, thank you. Not sure yet. And the last question, do you plan on trying to implement one of these activities you learned about today and record a report using a smartphone or other device? Yes, no, I plan to implement the activity, but probably will not record and report it using a smartphone or other device. Let's see if we can hit 80 this time. Yeah, we did it. That was quick. Awesome. I'll actually give a few more seconds to see if I have any last stragglers.
I wasn't sharing my screen. Sorry about that. There it
So I'm
is.
going to share the results. Yay, high five. That's awesome. I'm so glad. And yes, we would have many of our participants would join us in an upcoming citizen science event. I hope it's for Saturday. And the last question, yes, they plan on doing the activities. Thank you so much, everyone.
Yeah. I see one more question. You're welcome to stay for one more minute if you like to ask any questions you may have, but this pretty much concludes our webinar. So thanks for all of you who have joined us. I see some familiar faces, so I'm super excited for Saturday.
I believe that they were asking for the link for registration, so I am sending it now again in the chat.
It's bit.ly/SLSD, so for Sea Level Solutions Day event. So it's right here on the screen, and you can also use your QR code or your camera to scan this QR code.
Thank you so much, everyone. Hope to see you on Saturday.
All right. Bye, everyone.
Or
Thanks
hope
again.
you come out on Saturday. We won't be seeing each other.
Bye.
Just realized that.
All good.
Bye, everyone.